Okay. Right, structured query language. So what is SQL? What have we done? Probably quite a lot of this. Some of this is just reminding because it would have been a different week. So we know structured query language, relational database definition, control, and manipulation. We know that. Originates back with the relational model in the 1970s. It's an ANSI, which is American National Standards Institute, if I remember correctly, an ISO, International Standards Organization standard. It's what's called a declarative language. So a declarative language is a language, a computer language, where you state what needs to be done or what should be done, but you don't have to say how it's done. Okay? That's different from a language like Python or something that has lots of if-then loops, which basically you write a program that tells the computer exactly what to do. Do this, then do that, then do that. This just says, give me this, basically, and let the machine work out how to do it. Other examples of declarative languages include HTML, CSS, things we'll learn about for the web. And as I've said, the implementation standard varies between software. What is Postgres? We know, high-end RDBMS. It's sometimes called an object relational database, not just a relational database, as it does support some aspects of the object model. We'll have the object model in due course in some detail. So sometimes you might call it object relational. It's just because it's sort of got some object capabilities, but is primarily a relational database as far as I'm concerned. It originated in the 1980s, so it was one of the early database products, and it was called Ingress in those days, and it was a product developed at UC Berkeley in California, and it became a commercial product company. The company got into financial difficulties in the mid-90s, and the code, rather than just commercially die or be taken out, have the assets taken over by some whatever these corporate people are who dissemble companies, what they did was made the code freely available to the community, and it is one of the biggest open source projects that there is, and longest going open source projects that it is. So it's a commercial thing that went bust and became free and open source. It tries to be standards compliant. So the documentation presently says it supports 150 out of the 164 features of SQL 2003, which is the standard for SQL. And they state that no current version of any database management system fulfills all the criteria of core SQL 2003. Supports many extensions, including the PostGIST extension for spatial data, PG routing, which allows you to do spatial routing algorithms, and it follows the Open Geodata Consortium, OGC. Have you ever heard of the OGC? Some of you. Standards for spatial data. So basically the OGC, the Open Geodata Consortium, are a sort of group of academics, companies, GIS companies, vendors, users, who come together and specify standard ways of distributing and communicating about spatial data. Okay. So it generally tries to be standards compliant. How popular is it? Oh, well, difficult to compare the population. How do you know how popular a piece of software is? It's actually quite a difficult subject to actually answer. For example, that you could count the number of downloads, but just because I download something doesn't mean I use it, or I might download it once and use it 10,000 times. So download statistics are not a great indicator of usage. Also, download figures and sales figures are maybe not actually provided by many commercial companies, so how can you compare it to Oracle if Oracle don't provide the data, comparable data? So dbengines.com, which is a sort of website run by an Australian IT company, provides a rank score for DB usage calculated on a whole variety of metrics for trying to work out what is popular software and what isn't. You can read, I'm going to sort of skip over some of this because we're running behind time, but basically Here's the main databases. There's Oracle. Is still the main three are Oracle, MySQL, and Microsoft SQL Server. So two commercial products, Oracle and SQL Server, and MySQL, which is now an open source product, but has limited functionality compared with Postgres. Postgres, you can see down here as the sort of second part of the second tier of databases. So it's not perhaps the most popular in the world, but it's up there, and certainly as an open source one with a fully, as I say, it's the most fully functional open source spatial relational database there is. Okay, we've seen it, Postgres, PostGIS. The PostGIS is the spatial extension to Postgres. We can access them through different things. Okay. COD. Going back to COD. So COD invented the relational database model. We know that the relation, and he defined 8 relational operators. Now, relational operators are functions or operations that you can do on relations tables. And these, COD defined these 8 relational operators. And these operators underlie the logic of how relational databases work and SQL interacts with the data. They are the stuff underneath the hood of the engine. We just have a little peek under there. We're not going into the details of what goes under the relational database, but this is kind of your standard history of or what is a relational database thing. So it's built on top of these 8 relational operators, and what these operators do is they work on whole tables and give you the results of combining tables in different ways. Some of these map onto SQL functions very simply. Others are don't map on very well. Anyway, I'm going to run through these really quickly. These are detailed in the notes, but frankly, I've decided after a few years of teaching databases that actually I never need to know about these, except when I'm teaching you lot. I don't think you need to know anything about them to actually practically use a relational database. As I say, it's just a peek under the hood to see what the various bits are. So I'll run through these incredibly quickly. We've got one called select or restrict that limits the number of rows, tuples, based on some kind of conditional value. And that maps onto an SQL where clause, very simply. There is one called project, which returns, instead of a subset of rows, a subset of columns. So simply return me the name and age fields from a table. And those are implemented by listing the fields to return in an SQL query. And I'll go on to the details of SQL. If you're saying, why is he telling us this SQL? He hasn't told us anything about the SQL. Well, that's what the main bit of this lecture is about. But I thought it was just useful to point out the relationship, or some of these have stronger and some not so strong relationships with things you do in SQL. There's a join relationship, which does exactly what SQL join does, returns tuples from 2 relationships on the basis of matching column values. So that's implemented in join. There's a join clause. They have a product operator, returns tuples from 2 relations that contain all possible combinations and tuples from the source relationships. So we've got 2 tables here, A, B, and table A containing the values A, B, and C, table T, B, D, and E. The product of these 2 tables is 2 columns with all the combinations of values in the table. No SQL equivalent. Union returns all tuples from 2 relations that appear in one or both of the relations. So table A has A, B, and C. Table B has A and E. What are the ones that appear in one or both A, B, C, and E? Intersect returns all tuples that appear in both relations. In this case, A appears in both of them. Difference returns a relation that contains all the tuples that appear in the first, but not in the second of the relationships. But not in the second, so this is non-symmetric. So all the tuples in the first that do not appear, so A, B, and C in the first, A and D in the second, B and C don't appear in the second relationship. If we did it the other way round, we'd have E because E appears in B but doesn't appear in A. Divide takes two relations, one by, this is the slightly more complicated one, two relations, one binary, one unary. Unary meaning just has one value in it, binary having two values in it. Returns tuples of all values in one column of the binary relationship and matching the other column of all values in the unary relationship. So, one binary, one unary, binary relationship, unary relationship. Returns tuples of all values in one column, in this column, and you've got to match the other column. So we've got X and Y, so A goes with X and A goes with Y. B, A. All right. Returns tuples of all values in one column of the binary relationship that match the other column. Oh, it's because it's BX and, oh, it's because it's got X and Y. I think we'll leave that one. Does my head in. As I say, it doesn't matter. It doesn't matter. It doesn't matter what it does. Those are the functions that underlie it. As I say, I've never had to think about it. I do understand it when I can get my brain around it and I'm not going at 90 miles an hour. Okay, so Postgres. So forget that. We've looked under the hood. There's all these things. There's these 8 things under the hood. Great, shut the hood. Now let's get in the driving seat and find the steering wheel and the accelerator and the gears. Right. So what I'm going to do is going to show you some Postgres, some SQL in Postgres. And I'm going to use an illustration of an example of a database of cities, countries, and languages. First of all, a few rules. Object names, which some of you have discovered already. Object names that contain capital letters must be enclosed in double quotes. So city, if you type city as a table name, it is not going to be recognized. It's going to throw you an error. If you put capitals in, you have to double quote it. If it's all lowercase, it's great, you don't need to double quote it. Stay lowercase, avoid funny characters. Whereas strings are single quoted. So if you wanted to set the value of a text field, you would be setting a string, which is single quotes. So single quotes to define strings of text. Double quotes to define database objects that have capital letters. Okay. Semicolons. Strictly, according to the SQL standard, you should end an SQL statement with a semicolon. But as you probably discovered, you can run an SQL command without a semicolon at the end, certainly in the pgadmin3 interface. But if you had a whole string of commands that you wanted to run together, then if they didn't have the semicolon at the end, it would throw an error. So it's always a good idea to include the semicolon. And then when everything goes wrong, so you've done 2 weeks of work, your VM crashes and dies, but you've got a copy of your SQL file that you'd saved on your native operating system, you run that up, you just select all the commands in your SQL command, run them all, and it rebuilds everything that you've done before. So even if you get a corruption, you can save the day with a good, well-formatted SQL file. So include them in your file. I do recommend including them. But you will see slides and bits where I've forgotten about them. So just accept the time for error. Right, code style. Readability. Whenever you are writing code, try and be neat, tidy, and consistent. So you may think, well, surely, so indentation is a good thing to do. So indent various bits of the commands. And it may seem meaningless at this point, and you're quite right. You know, that's 10 words, not even 10 words. The indentation doesn't really make it any more readable than if it wasn't indented. But if your SQL query is this size, 25 lines, including several subqueries and things like that, then it becomes really important that you make it readable, and indentation can help. Personally, I always like writing my SQL commands in capitals. That's actually not what the standard says. The standard sort of, or the guidance is to write them in lowercase, but personally I prefer writing them in lowercase. Then I can see what is SQL and what is my fields and tables. That's personal preference. Anyway, the bigger your queries become, the more important it becomes to organize your code sensibly. All right, create a database. Well, we can do that with a create database command. So this is me making my country database. I could also do it by right-clicking and going on in the pgadmin 3, going new database. There's my new database. I've called it world here. And in this case, if we select that, we can see in the right-hand pane that we've got a description of this database here. It's cool. And it provides us with the SQL that you would need to type to create that database as it is, or at least some of it. So I just typed create database world, but as you can see, there's a whole load of sort of default settings here as well. So I'm the user, so it's owned by the user who created it. You can also see that the standard character encoding is UTF-8 on the Linux machine. So we can get information about these data objects by highlighting them and then looking in that SQL pane on the right-hand side. So my city table, create table city. It's got an ID, an integer, not null, a few different fields. That's easy enough. We don't need to worry about that. We've also got a country table. This is the definition for creating the country table. As you can see, we've got a lot more fields here. Some small integers, so relatively small numbers. One thing I want to point out over here is that the country code is or the character 2, code 2 is, first of all, it's got a null, so that's got a null constraint, sorry. The next one is, the next line here is we've got a constraint defined on the country continent field, which is oh, it's actually defined here, is that correct? Yep. Okay, so then we have another field. Our last field in the table is called country continent, and yeah, I can't see it where else it is. It's not defined there, is it? It's continent. Ah, no, here it is. So here we've got a field called continent, which is a text field which has to be not null. Every country has to be in a continent. Here we've got a constraint called country continent check. That's the name of the constraint. And what it implements is a check constraint. And that check constraint makes sure that the continent is either equal to Asia, or it's equal to Europe, continents Europe, or North America, or Africa. So we can only enter values in this list into the continent field. Yeah? So every time we enter new data, it runs this country continent check constraint and sees whether it matches any of these fields. By the way, this double colon and then text is what's called casting. Basically, it's defining this, it's turning this, what is ostensibly text, into a text data type. So this is text, but as we've known, there are different types of text. There is things like varchar and character and text fields, and so there are all varieties of different types of text field, one of which is called text, and this double colon text means this is interpreted as a text data type field. We'll be meeting that in due course. Country language. So this is a table that contains the country code and then has one record for each language. So each row has a country code and then a language that's spoken in this country. It's got a Boolean field, yes, no field, that says whether it's the official language or not, and then it's got a number, a real number, that tells us the percentage of the population that speaks that language. Okay, I've created my tables, so I've got a whole load of I've now got my country table, my city table, and my language table, but no data. So my city data, in fact, all the data is in text files, just like your data was in the used cars. But as you can notice, in this case, it's not a comma-separated file. These are tab fields. So it's a tab-separated file. So we've got the unique ID, we've got the name of the capital, we've got the country code, we've got, I think that's a local, that's a sort of non-English name of the town, if I'm correct, and that's the population on the last field. So we loaded in. I used the copy command, just like we did for the used cars, and define which fields. I don't actually need to include this because the fields in the file are in the same order that they appear in the table, so I wouldn't actually need this command. But this is quite useful if the fields in your database are defined in a different order or the columns in your database are defined in a different order from what they are in the text file. You can define the ordering in the text file. From, well, there's the location of my file that I want to load up. And then in this case, I've got a slightly different format to what you used or is in the practical documentation. I think this is the new version 9 syntax, and I probably suspect you're using the old version 8 and below syntax for defining the type of the thing. They change these, there are often different ways of specifying it. In this case, I've got the with style. It's a format as a CSV file, it being a tab-separated file format, but we can define the delimiter and as a tab. I got this field here by just typing the tab key on the keyboard. I had to look that up because I couldn't, because it used to be /t meant tab, but that doesn't work anymore. You now actually have to write in a tab and use a tab key on the keyboard. Okay, so that was easy for the city file. Here's the country file. The country file is very similar. It's a tab delineated format, but in this case, when I look through the file, so this is one line of text out of the country. There's these /n's in here. What are they? Well, they're indicating a null value. So as I said, I think in a previous week, that all sorts of different characters are used sometimes to represent nulls. In this case, /n is being used as a null character. So in this case, to load the file up, what I had to do was I did my copy, country, ... That's just because there's an awful lot of fields that I can't be bothered to list there. So that's all the list of fields, from, the address, .txt. And in this case, CSV wouldn't, the CSV format that I used on the previous one doesn't by default pick up these /n's as nulls, but I discovered it by reading the documentation, or actually by searching Google for how to load in with /n's into a Postgres table. I discovered that in fact I've got to use the text format as opposed to the CSV format, which automatically recognizes these as null values. And the delineator is the tab again. So despite the fact that ostensibly I've downloaded the data from the same place, I'm actually having to use slightly different commands to load the data up into the database. I could have used this on the previous one and it would have worked absolutely fine, but I didn't need to because it didn't have these /n's in it. So look through your data file and make sure you know what the designation of null values is. Then we set the primary keys on the city country tables. Notice here that on the country language table, we're setting a composite primary key because every record in that tape should uniquely identify a language in a country. You shouldn't have more than one record for each language in each country. Yep. So therefore, we can define a composite key based on the country code and language value in that field. There we go. We've got now our new city table with our constraints. Foreign keys. Again, we've got a foreign key on the capital. So a capital city in the country table must equal one of the values in the city table. So we can't have a capital that isn't in the city table. Yep. And also we've got a constraint on country language, which tells us that the country code must be in the country table, the code table, the code field of the country table. Voila, that's what our country table now looks like with our foreign keys and our primary keys defined. We'll just finish this bit and then we'll go up to the next. Database maintenance. Whenever we load data up or create new data or edit data in the table. Oh, right, let's reverse myself. Relational database systems decide how to undertake queries and to do things on the basis of statistics on the tables that are stored in an internal catalog table called PG statistics. So this is an internal hidden table. I mean, you can get to it, but it's not something that you see listed. It's buried within the system. And this contains statistics that are used by the system to plan how to undertake a query. Every time you update and load information into a database or edit data, the data doesn't automatically get deleted out of the database, the old records. They're kept in there until you decide to basically have a housekeeping exercise and clean them all up. So when you load in new data, the statistics don't update. Okay, so you load in new data, the statistics doesn't update. So following a data load or update, you should run these analyze commands, and what they do is they go through the table and they update the statistics in the PG statistics table, which increases the performance of your database. Okay, so it's got using the most up-to-date. So when you create data, add it. I was getting confused there with the second thing, which was vacuum. So whenever you edit data in a database, it's not actually deleted off disk. It remains on disk, but it's just kind of flagged as being old and out of date. So basically, the more updates you do on the database, the larger your database becomes, the slower it gets. So once you've deleted or updated a whole load of records, it's a good idea to do some garbage collecting by running what's called the vacuum command. And I think by default it came up last week and warned you about vacuuming, and people say, should I vacuum? Yeah, just vacuum. If it says vacuum, then give it a vacuum. So that gets rid of old records that are clogging up the system. Right, okay, let's stop there. Okay, now we either have a choice. Either I carry on with the SQL lecture and try and get it out the way when we go upstairs, or, which might be a good idea, or we can just carry on with the doing the SQL. I suggest I plough through the lecture as fast as I can, and then we're kind of up to date again. But if you'd rather do the actual practical, we do finish off the lecture next week. I'm easy. Show of hands, lecture. 2, 3, no lecture. Go on, commit. 1, 2, 3, 3 for no, and 3. Oh, you're the decider. All right, well, if you change your mind between here and now, getting upstairs, then we'll do that. That's, yeah.